If you've ever watched a train speed by, you intuitively understand how motion works in our everyday world. This diagram shows a girl on a train moving 10 meters per second. If she throws a ball forward at 10 meters per second, a ground observer sees the ball approaching at 20 meters per second. The speeds simply add together. This additive property is how we experience the world. It's the completely logical foundation of classical physics. But let's swap out the ball. What happens if the person on that moving train shines a flashlight forward instead? In 1887, Albert Michelson and Edward Morley proved the speed of light ignores the train's speed. Whether a flashlight is stationary or speeding towards you, the light approaches at the exact same rate, 300 million meters per second. Speed is just a measure of distance divided by time. If the speed of light is a rigid, unbreakable constant for every observer, no matter how fast they are moving, then distance and time themselves must be bending to make the math work. Albert Einstein realized that because light speed refuses to change, everything else we thought was fixed has to adapt. This graphic illustrates his famous thought experiment, a clock inside a moving spaceship that measures time by bouncing a single pulse of light between two parallel mirrors. Up is tick, down is talk. Inside the ship, light bounces straight up and down. To an outside observer, the mirrors move forward, forcing light onto a longer zigzag path. Since light can't accelerate to cover this extra distance, the clock's ticks take longer. Time itself runs slower. This illustration highlights another consequence. Space contracts. An observer moving near the speed of light actually measures shorter physical distances in the direction they are traveling. Space and time are not an empty grid and a universal ticking clock. They are flexible dimensions that warp depending on your personal speed. Why can't you just keep accelerating past the speed of light? Because as an object moves faster, its mass increases. Near the cosmic speed limit, kinetic energy stops making the ship faster and instead converts directly into physical mass. This chart shows how mass and energy are entirely interchangeable, linked by the equation E equals mc squared. Even the tiny mass lost in the radioactive decay of carbon-14 yields a massive release of energy. This chart compares ordinary matter particles to their antimatter twins. Antimatter has reversed properties, like a negative charge on a proton. When matter and antimatter meet, they annihilate each other, converting 100% of their mass into pure energy. This illustration demonstrates the sheer scale of that conversion. A grain of sand made of antimatter colliding with normal matter would release 400 trillion joules of energy, enough to power a small city for nearly a week. Matter is highly concentrated, frozen energy, strictly governed by the absolute speed limit of the universe. If nothing in the universe travels faster than light, we hit another problem: Newtonian gravity. Under the old rules, gravity was supposed to act instantly across vast distances. If the sun suddenly vanished, we'd see its light for 8 minutes and 19 seconds, the time light takes to reach Earth. Earth would also continue its normal orbit for that exact duration, because gravity moves at the speed of light. To explain this, Einstein reconstructed gravity entirely. Gravity isn't a pulling force. The presence of matter and energy physically deforms the invisible, four-dimensional fabric of spacetime. Planets orbiting the sun aren't yanked by an invisible tether. They are simply rolling along the curved topography the sun carved into space. We do not live in a clockwork universe built on a rigid grid. We live inside an interactive, four-dimensional structure. Time travel into the future is a legitimate physical reality, entirely possible if you can travel fast enough. The solid objects you interact with every day can be born from and return to pure invisible energy. From the daily flow of time to the crushing density of a black hole, where time itself stops forever, these rules govern everything. The speed of light is the absolute constant, and its strict rigidity is the exact reason our cosmos is so wonderfully flexible.